Hi everyone, today we're going to be looking at the Easyplc Machine Simulator Productivity PLC Robotic Cell. Now the Machine Simulator, or MS, is part of the Easyplc software suite. It has many built-in machines that are used to show different programming techniques. The robotic cell example is one of these machines. This will demonstrate a sequencer example. The logic will step through different steps in order to perform the task. In this case, an engine is lifted and placed onto a rack or pallet. We will be using a Productivity Suite programming simulator to program this engine loader of the robotic cell. This will be done using Modbus TCP or Ethernet for communications. Using the 5 steps for programming development, we will show how the sequencer is programmed. Let's get started. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there'll be links in the description below that will start your video 1. There'll be links to the rest of the videos in the series as well. So the first thing we will do is go to our simulator, and the very first step is to define the task that we must do. So hitting the start, we'll go into the number 13, engine loading, and we'll look at, we'll just click on that unit itself. Over here on the left hand side, it will actually show you the description of what has to be done. In this case here, use the industrial robot to load the engine blocks in the pallets. Manage the conveyors, stops, to place the parts in their position, and the robot to load the engine back to the pallet. Once loaded, release the pallet. So that is the process that we want to do. And what we'll do is look at the demo mode that we have for engine loading, and that will load up. And you can see here at the bottom that we have our demo mode, and you see the pallet coming out. We have a stop here on the conveyor, as well as a stop over here as well that has to be controlled. So the robot picks up the engine. It will then place it into the pallet once it obtains the spot here. Releases it and goes back up, and then allows the engine with the pallet to release down the conveyor, and the next items then start. The next step is to define the inputs and outputs. So if we look at the view IO, you will see that this will show you exactly all of the inputs and outputs that are required here. You will see that we have a conveyor 1 and 2 advance, which are these. We have our stop 1, which is here. We have our robot fix part, which allows the robot fixture to pick up the engine. We have a stop 2, which is over here. We have our robot home, take part, lift part, load part, and elevate robot. This is all movements of that robot itself. And we have an engine create, which comes out of this door, which the engine comes out. And we have a light 2 visible, which is actually a pallet create, which comes out of this area here. Then finally we have our beacon or stack light, which controls the green, amber, or yellow and red light here. So that is what we actually are controlling on the output side. And on the input side, we have our robot detect. We have our robot stop. So this is the stop movement. And then we have 2 inductive switches, one for each spot here on our conveyor. So when the engine reaches this point, it'll trigger, as well as we have when the pallet reaches this point, it'll trigger. So after we've defined the inputs and outputs, and we know exactly what we want with those inputs and outputs, the next step is step 3 of our program development, which is develop a logical sequence of operations for this robot. In order to do so, what we do is we can use a sequence chart, and I'll call up a sequence chart that I've created here. And you can see that we have inputs and outputs that we are going to be controlling. And along this axis here, we have all of our outputs that we control, and our inputs come from this side. So when we output our outputs, that sets the outputs that we want to happen. Then when our input condition is true, it sets the next one out. Next input, true, it sets the next one. So it goes along into a sequence of events. This tells us every part of the program that must be programmed in a logical sequence. So once we have that all laid out, and we understand fully, because we have to understand exactly what's going to happen, especially if we have power failures or We're going to start it up. Once we have all this in, then what we can do is go on to our step 4. Now keep in mind, step 3 is where we're actually going to be doing all of our main work and trying to develop what our sequence of operations is going to actually be. So you're going to spend a lot of time doing the logic and making all the errors here first. And it'll prompt a lot of questions. And those questions should be answered prior to you actually doing the programming. Because the more questions get answered in this step, the less of the ladder logic that we have to actually program and continuously program to make up for errors. So as a programmer, you must fully understand all of what exactly has to happen within your sequence. So after we have our logical step, next step would be to develop the Productivity PLC program that we have. So let's call up our software. And here's our software that we have for this unit. And what we have is a start robot cell, and then it sends a robotic cell run output. And when that robotic cell run, then we look at if there's a time delay as part of that sequence of operations. As you saw there, we have a simple timer for half a second. And if the robotic cell is running, then we enable our unpack bits, which takes our sequencer output and through a pointer, so that's indirect addressing, we will unpack those bits and control all of our different outputs that we showed in that previous chart. So we have 15 of them here. So we have 14 actual physical outputs from the machine simulator. Next, what we'll do is when it's not running, we actually copy 0 and 1 into our beacon light, just to make sure that if we hit stop, then everything then stops. Next, what we have is our pack bits. And on our pack bits, what we do is we take all our inputs, so our robotic detect, the stop motion, and the inductive switches, our robotic run, the cell run, which we had on the first rung, and we have a time delay, and we put that to an output sequence. So that becomes our input word that we're comparing to the previous chart. And what we have is we have a robotic cell running, then we compare our input source word, then we compare it to our actual input itself. If they're equal, then we increment our pointer, and if our pointer is greater than 6, which is the last step of our sequence table, then we move 1 back in or reset it. We also take a look at the first scan bit, and we will reset that pointer also back to 1. So that is basically what the program is. Now the next step here, what we have is we've used a Productivity 2000, which has a screen on the CPU, which we can actually put information. In this particular case here, we're putting ACC Auto on the first line, Easyplc on the second, Robotic Cell on the third, and we're putting a message saying what step we are actually on. And we use the pack string to indicate we're going to put in step 5, and we're going to put a pointer in there, which tells you what step that unit is on. So we can monitor that as we operate. So once we have that all set up, what we next need to do is to actually test the program. So before we do that, we're going to turn on the simulator. When we turn on the simulator, we're going to transfer that program to the simulator. And once it's transferred, we're going to make sure it's in run mode. So now we are in run mode on our Productivity PLC. So we're all set here at this location. Next, what we want to do is we want to go back to our machine simulator. And currently right now we're still in demo mode. So let's exit out of that mode. And when we exit, what we want to do is call that machine simulator. We can go to machines, go to engine, and we'll go to the start. And the first thing you'll notice is that we are not connected currently to any PLCs. And our I/O drivers here. So we'll click the I/O driver, and we will call up our Modbus driver, and we will hit configure. You'll notice that once we call the Modbus driver, our PLC inputs here and our PLC outputs are right here. that we require for our program. So we hit the configure. Once we do that, you can see that we have our TCP IP address 192.168.1.3. That is the IP address for the machine that you're running the simulator on for the Productivity Suite software. Our digital inputs will start at 0, and our digital outputs number will be 14 because we have 14 digital inputs coming into this machine simulator, which is the outputs to the PLC. And then our digital outputs are 4 that are being given to the PLC, which would be PLC inputs. We don't have any analog inputs or outputs in our scaling factor, so we don't have to worry about that. And we just hit OK. Once we do that, we have our inputs and outputs now over here. We can manually move those into our inputs and our outputs into our driver inputs into our digital outputs, or we can just hit driver and then automatically assign. When you do that, you see it automatically assign it in order, and then we can exit and start driver. Now you will see that we have our driver connected. If we want, we can call up our UIO. And without the PLC connected, we could actually turn this on and off and determine exactly what step each one of these will do. However, we have that now running, and the only thing else to do now is go back to our Productivity Suite software. We will go to our tools and call up our data view. Now with our data view, it shows us our input and output. Here's my input sequence from our table. You can see my output sequence from the table here, and our pointer location. Over here, we can actually see the unit itself, and you can see here's my screen display that we have, and we're on step number 1. And on this, we can go back to the beginning of our program here, which will show me the run. So this first input here is actually the run. The next one is the stop. And this first output here is actually the run will show us that the robotic cell is running. So what I'm going to do is just move this out of the way here, because when we start it, we want to see what happens. So I'll just move that down a little bit, and we will hit start. And now our program is actually running. So our start input. So we have our engine coming out. It'll be actually going to this first input here, and as those input conditions are met, then it will go to the next sequence, which is sequence number 2. And this is waiting for the pallet to be over here. It then picks it up, puts it over, and then places it onto the pallet. It then releases it, elevates the robot, homes it, and then the sequence continues. So you see all the different sequences, and as our pointer increases here, we can also see our pointer increasing on our actual CPU. This would be ideal when we try to troubleshoot. Now, the things we can also do is, as this is running, if we go into the machine simulator or back into it, you can see that we have a time elapse mode here, and we can actually speed that up a little bit. So we can do twice the speed. Then we can move around this in either the first person, or we can actually automatically move it around and watch this operation. We can give it a little more speed and actually go to 3 times. So the Easyplc machine simulator is very good for teaching how to program PLCs. Now, if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.